Let's get some practice assigning the configuration of a double bond. So every double bond has 4 groups attached to it. They might be the same 4 groups, like ethylene would have 4 hydrogens attached to it, or they could be 4 completely different groups or some combination. So in this case, the first drawing I have here, one of the groups on the left carbon is an ethyl, the other group is a hydrogen. I haven't drawn it in, but we can mentally fill it in with our minds. On the right carbon, I've got a methyl, and I've got this 4-carbon group, sec-butyl. So I have 4 different groups attached to this alkene. That's what we want to focus on when we're figuring out the configuration here. So I want to now use Cahn-Ingold-Prelog rules, the same rules I used for RNS configuration, to establish which group on each carbon is the highest priority group. So I'm going to have 2 groups that are considered the highest priority, and I'm going to circle those. So on the left carbon, I have a hydrogen. That's probably not going to be the highest priority. And I have this ethyl group. So let's circle the ethyl group. That is highest priority on the left carbon. Let's look at the right carbon. I've got a methyl, and I've got sec-butyl. And of course, I've got the branch point and more carbons. This group is the highest priority. So I've circled those groups. And now I'm going to, generally I imagine a line parallel and through the alkene. You can draw it at first if it helps you. So that line sort of defines 2 sides of the alkene, and I'm going to label those sides, I could do top or bottom, but I'm going to do left and right. And now we want to figure out those circles that I drew, how are they related across that line? Are they on the same side of the line? Or on the opposite sides of the line? What do you think about these 2 circles? They are on opposite sides, right? And so that leads us to E, which I believe is derived from Entgegen. You can correct me if I'm wrong. If you're a native German speaker, I apologize for butchering the word, but it means something like opposite in German. And so this would be an E alkene. So that's the procedure we're going to look at. We're going to look at the 4 groups that are attached to the alkene, the carbons that make up the alkene, and then we're going to circle or at least identify where the highest priority group is. Let's look at this alkene on the bottom. On the left carbon, T-butyl versus hydrogen. T-butyl is much higher priority than the hydrogen. On the right carbon, I have a bromine versus propyl. Bromine has a higher atomic number, so that is the higher priority group. Take my imaginary line, and you can see that both of these circles are on the same side of the line. That comes from, I believe, the German word zusammen, or some pronunciation thereof, which means something along the lines of same side. I like to remember it as zusammen, Z, same side, when I mispronounce the S in same side. So that is a Z alkene, meaning it's on the same side. The highest priority groups are on the same side. Here's another example. I have the left carbon. The isopropyl is the higher priority group here. On the right carbon, I have a T-butyl group and I have an OCH3. So this is interesting. I have an oxygen now attached to the carbon of the alkene. So the carbon here versus the oxygen, that's going to be the distinguishing feature in priority here. O has a higher atomic number than does carbon. So I'm going to circle the OCH3. Again, my imaginary dotted line, we see that these 2 circled groups are on opposite sides. This is an E alkene. On the bottom of the page here, I have a hydrogen versus ethyl. The ethyl is higher priority. Right here, I have an ethyl group, and I have another ethyl group. So I don't have any priority here. Right? These are equivalent groups. What happened when we had 2 ethyl groups attached to a carbon bearing 4 substituents back when we were establishing absolute configuration for chirality centers? What happened when we have 2 of the same group attached? Well, we didn't have a chirality center, right? So in this case, I don't have any stereochemistry of this alkene. So this would be no stereochemistry. And if I ask you to write this answer on an exam, you can certainly abbreviate that with NS as opposed to E or Z. So this has no stereochemistry. So don't make the mistake of thinking that every alkene has to be E or Z. Some of them are neither, and that's because they generally have two of the same group attached to one of the alkene carbons. One more example here. On the left carbon, I have an ethyl group, and I have an ethyl group, but it has a chlorine on it. So which of those do you think is the highest priority group? Probably the one that has both a branch and a heavier chlorine atom. So that's going to be higher priority there. Then on the right alkene carbon, I have OCH3 and I have O-ethyl. Which of those do you think is higher priority? Well, the O's are the same, so we're going to go further along the chain, just like we would for R and S. Now we have a carbon from a methyl group, a carbon from an ethyl group. Those are also the same, but I think as you're getting the picture here that the methyl is not going to be higher priority than the ethyl. So the longer chain in this case is going to be highest priority. So let's give that a circle. So again, we have more carbons on that chain. It has the higher priority. Drawing our dashed line, perhaps you don't need the dashed line anymore, but these are obviously on the same side of that dashed line, and these are the Z configuration.